I'm Sai Srirampur and I'm the CEO and co-founder of PeerDB. At PeerDB, we are building a data movement and an ETL tool tailored to Postgres. Today, I'm here to talk about what does it take to build a Postgres specialized data movement tool. Before I get started, I would like to share why there is so much love for Postgres in the community. First, Postgres is open source. It has a large developer and a support community. Number two, like any other traditional OLTP database, Postgres has features like constraints, indexes, and so on. Number three, Postgres has a very rich extension ecosystem. What that means is you can actually write extensions which are very similar to libraries to make Postgres more powerful. For example, you have the PostGIS extension to build enterprise-grade geospatial applications. Postgres also has a very rich data type ecosystem. For example, you have the JSONB data type, which lets you efficiently store and index semi-structured and unstructured data. And this actually brings NoSQL capabilities to the SQL world. And it's very common in IoT kind of applications where you have a ton of semi-structured and unstructured data. And last but not the least, Postgres has a very rich SQL interface, and that these days is becoming the standard for databases. For example, new databases like CockroachDB, Spanner, and all of those have a Postgres interface. It also supports advanced constructs like window functions, CTEs, full text search, and so on and so forth. And because of this love, there is a drastic increase in adoption as well. The visual you're seeing on the screen is from DB Engines, which is a very reputed website which ranks databases. And if you see, Postgres is the only database across the four top databases, which is Oracle, MySQL, SQL Server, and Postgres, which is growing in popularity. And yes, this is translating to a drastic increase in the amount of data that is being stored and moved through Postgres. During my times at Citus and Microsoft, where I worked very closely with Postgres customers, I saw enterprises having a fleet of Postgres databases with terabytes of data stored in each of them. Even with all of this, Postgres still lacks a first-class data movement tool, a tool that reliably supports any use case to move data in and out of Postgres. Not to say that existing ETL tools don't support Not to say that existing ETL tools don't support Postgres. They do support Postgres, but Postgres is one of the 100 connectors they support, right? They are not tailored and optimized for Postgres. And here I have the common issues that we have heard from Postgres customers using existing ETL tools. First, existing ETL tools are slow. Moving Postgres databases with terabytes of data can take multiple days to weeks. They don't support real-time replication. Say you want to replicate data from Postgres to Snowflake, the minimum latency they support is 15 minutes, and that can exponentially grow at higher throughputs. Existing ETL tools are not reliable at scale. One of the common concerns that we hear from customers is replication slot growth. I'll double-click into this particular topic in my future slides, but because of replication slot growth, the Postgres database itself can crash. Third is they don't support native Postgres features. For example, native replication of advanced data types like geospatial, JSONBs, arrays, and so on. And last but not the least, the pricing models are usage and amount of data transferred based, which could lead to costs quickly spiraling out. And the solution for all of these problems is a data movement tool that is tailored to Postgres, a tool that implements every intricate Postgres optimization to provide a fast, reliable, and a native data movement experience for Postgres users. And that is what we are doing at PeerDB. We are building a data movement tool tailored to Postgres, and we implement multiple optimizations around Postgres, and we are targeting two main use cases. One is replicating data from Postgres to data warehouses like Snowflake, BigQuery, ClickHouse, and then Postgres to queues and message brokers, which includes Kafka, Redpanda, Google PubSub, and Azure Event Hubs. What you're seeing on the screen is a bunch of Postgres native optimizations that we are implementing within PeerDB, and let's do a deeper dive into a few of them. The first feature I want to call out is the parallel snapshotting feature. This is to efficiently move large data sets from Postgres to any target data store. So the target data store here you're seeing is Snowflake, right? Internally, Postgres has a has an internal identifier called CTID. CTID represents the exact location of the row on disk. It is a tuple which represents the page number and the offset within the page number. What we do within PeerDB is we logically partition the large table based on CTIDs and parallelly stream them to the target data store. Now there are two benefits with this approach. So the first is you're accessing table data in the order of how it is stored in disk. That is one. The second is you're able to parallelize these large data loads, right? And the results are pretty incredible because you are able to move terabytes of data within few hours versus days. We recently had a customer who was not able to use an existing ETL tool because they had a table which was over a couple of terabytes, and they were not able to move because the load was taking multiple weeks. And with this parallel snapshotting feature, we were able to get it within 12 hours. The second optimization I would like to talk about is always consume the replication slot. So Postgres has this data structure which is called a replication slot, which captures all the transactions as they happen in Postgres. Now ETL and data movement tools rely on the replication slot for change data capture or continuous replication to Postgres. One of the biggest risks with replication slot is that if the ETL tool doesn't consume the replication slot fast enough, the replication slot could grow and crash the Postgres database, and that is disastrous, right? Because your OLTP and operational database is running on Postgres. To help with that cause, we always consume the replication slot and flush those changes to staging areas it could be local or it could be remote staging areas like S3. Another optimization that we are working on is to consume in-flight transactions, right? So what I mean by that is transactions are not committed, but as the changes are happening, we consume it. Now, this would further reduce the growth of replication slot, but it's a very intricate feature because it is the onus of the ETL and the data movement tool to take care of transactional semantics because the transactions haven't been committed yet. Now, the third optimization is replicating data types as natively as possible, right? For example, you replicate double precision arrays in Postgres to double precision arrays in Snowflake instead of having them text on the target, right? Through this, data is already in the ideal format in the data warehouse that data engineers want, right? And through this, we have seen our customers save DBT cost by over 2x because you don't need to additionally transform data, right? You have text and you want to convert it to double precision arrays. Already the data is present in the most native format. Now, the last but not the least is providing alerting and metrics which are native to Postgres. For example, having alerts and metrics around replication slot growth, number of connections on Postgres, and last but not the least, what is the activity on Postgres, what are the wait events, and what are the bottlenecks, right? So to conclude, I would like to say that I don't think it's just the ETL tool which needs to improve to provide a first-class data movement experience for Postgres. Things need to change upstream, things need to change in open source. And here are a few ideas that I jotted down on what could go into open source to make data movement first class for Postgres. We are working on a few of them at PeerDB. And I'll call out a few of them, right? For example, having replication slots directly on remote storage instead of having them within the server. That is one. The second is, say you have Postgres does not support compressed data formats, right? It's a row-based store. It does not support columnar formats like Parquet, which really help with ingestion speed, right? And there are a few extensions I want to call out, ParadDB guys who are working on bringing columnar format to Postgres. Basically, there are other ones if you are seeing here. And yeah, that's it from my side. And hope you enjoyed the talk and learned what does it take to build a Postgres specialized data movement tool.